Alright, so in our last video, we went over our first two transformations. We went over translation and reflection. In this video, we're going to go over rotation and dilation. So this is the back side of our note sheet. So a rotation, you can see that there's the word rotate in there. And that's our clue for rotation. Our key word is to turn. So whenever they say to rotate a shape, we're going to be actually turning it, almost like how we can turn our paper. So our shortcuts here are a little bit confusing when you first write them down, but then when we end up using them, they become a little easier. So I'm just going to go through them and then we'll see how they actually show up. So let's talk about 90 degrees clockwise. So that means the same direction that the clock is going around. If I want to turn it 90 degrees clockwise, that's going to be like taking my paper and turning it one turn to 90 degrees. That's one turn is 90 degrees. So whatever our coordinate was, x, y, what we do is we actually swap spots for those numbers. So whatever was y is now going to be our new x. And then we make that second one the opposite. So it's y negative x is our rule. So as I'm looking at my triangle in my example, it says to rotate it 90 degrees clockwise. So I'm going to go ahead and use that rule. Well, first, let's go ahead and just write down what A, B, and C are. A is at -5, 7. B is at -2, 4. And C is at -5, 4. So remember, first we switch the spots. So my 7 is going to come first. My 4 is going to come first. And my 4 is going to come first. So I took those and put them first in my new coordinates. And now I'm going to do the opposite of the other number. So the opposite of -5 is a +5. The opposite of -2 is a +2. And the opposite of -5 is again a +5. So as you can see, using these rules makes it a lot quicker. So my new coordinates here, well, this kind of runs off my graph, but 7 would be just right off of it, and then up 5. So 1, 2, 3, 4, 5. So there's my A prime. And then I've got 4, +2 for B prime. And then 4, +5 for C prime. Go ahead and connect those dots, and I've got A prime, B prime, C prime. All right, now sometimes they're also going to say to turn it the other direction, counterclockwise. So remember, clockwise goes around like that, while counterclockwise would be the other direction. So if it's going counterclockwise, we still flip where the y and the x are, but this time the y gets to turn into its opposite. So I'm just going to go ahead and rewrite these. So -5, +7, -2, +4, and -5, 4. So again, I'm going to switch those spots. So I'm going to use 7 and 5. And remember, this time my y is going to turn to the negative. All right, so as I'm figuring these out, this time my first coordinate stayed the same and got flipped, while the other ones turned to the opposite here. So I'm just writing myself those little notes so I can see which ones stayed the same. So when I go through and I graph this now, I'm going to go, again, it's going to be just off, but we'll be all right. And then down 5, so 1, 2, 3, 4, 5 is going to be double prime this time. And then -4, -2, and that's B double prime. And then -4, -5 is C double prime. Connect those dots, and I've got A double prime, B double prime, C double prime. So it's almost going to end up looking like a pinwheel when we rotate a triangle around. So our last way that we can rotate a triangle is 180 degrees. Now, it doesn't matter if you go clockwise or counterclockwise, you're going to still end up in the same spot. Now, if we're rotating 180, the x and the y do not switch, but they do turn into their opposites. So down in our example, you're going to see that our -5, 7 is going to turn into +5, -7. Our -2, 4 is going to turn into 2, -4. So we're just taking the opposite and keeping those numbers in the exact same spot. So -5, +4 is going to turn into 5, -4. So what that looks like, because it's almost going to complete our little pinwheel. So this one has 3 primes on it, so a triple prime. So a triple prime is going to go over 5 to the right, 1, 2, 3, 4, 5, and then down 7. So 1, 2, 3, 4, 5, 6. There's A with 3 primes. B is at a 2, -4. And C is at a 5, -4. And when I connect those dots, now I've got A triple prime, B triple prime, C triple prime. And it does end up looking like a pinwheel, so that's one way that you can figure out that you did it correctly. All right, our last transformation that we're going to talk about is our dilation. And a lot of times, what I like to remember here is an eye. Remember, sometimes you can go to the eye doctor and you can get your eye dilated. And that just means that they're changing the size of that pupil part of your eye. And sometimes it gets really, really big, a really big black circle, and sometimes it's smaller. So that's just an example of the real world where we see dilation. All right, so again, this is going to be to grow and to shrink. So you can go either direction here. Either you get bigger or you get smaller. In both cases, our shortcut is going to be to multiply. If you are multiplying by a whole number, it's going to grow into a bigger shape. If you multiply by a fraction, it's going to shrink into a smaller shape. And we can see that with our numbers. So my first example says a scale factor of 2. All that means is that for every single number, we are going to multiply by 2. So 0 times 2 is still 0. 3 times 2 is 6. So I'm going to go ahead and graph that. 0, 1, 2, 3, 4, 5, 6. -1 times 2 is -2. 1 times 2 is +2. So that's a -2, +2. And then these are both going to be a +2. So 2, 2. And when I connect my dots, I see that I get a triangle that is 2 times the size of my first triangle. Now, if our scale factor was 1/2, that means that I'm multiplying every single number by 1/2 or 0.5. Remember, 0 times 1/2 is still going to be 0, but 2 times 1/2 is going to be 1. So you can see that it's going to be 0, 1. I know that those graphs are really small, but just do your best. -4 times 1/2 is a -2, 1. And then -4, 6 is going to turn into -2, 3. So -2, 1, 2, 3. Now this triangle is half the size of the other triangle. So between translations, reflections, rotations, and dilations, there are 4 ways that you can transform a shape, and each one has its own shortcuts. So what we're going to do is continue to practice them and see how they change our shapes in our future practice.